How you all doing today? This is Mr. Do the Math here, and I'm talking to you guys about multiplying fractions. Alright? Multiplying fractions is the same way that you multiply fractions. The way you multiply fractions in Algebra 1 and Algebra 2 is the same way you multiply fractions in elementary school. Alright? You essentially just multiply the numerator times the denominator. This is meant to say D over E, right? Numerator times the denominator. A times D is AD, and any number B times any number E is BE. Okay? Now, once we get into Algebra 1, Algebra 2 concepts, and we are multiplying not only numbers, but numbers and variables, there are some other things that we have to look for before we get to the plain and simple multiplication concept. Alright? And so the first thing you want to look for is, number one, you want to see if you can factor the two fractions. Are they factorable? Right? And if they are factorable, you factor them. Right? Then you want to, after you factor them, you want to simplify them or reduce. We used to call it reduce, but because of change in terminology and just using correct verbiage in mathematics, we say simplify. So you simplify it. So for instance, if you had something like 3 over 7 times 14 over 5, you can simplify this because of the numerator and the denominator. You can cross simplify. And I don't know if that's the correct term, but there's the greatest common factor between the two, and that's 7. So you can divide 7 from both of these and change 14 to be 2, and you change 7 over 7 to be 1. And what you've done is you still created somewhat of an equivalent fraction. So then you end up with 3 times 2 over 1 times 5. And your solution is 6 over 5. Alright, so that's the simplifying part, when you simplify something like this. And afterwards, after you simplify number 3, you just simply multiply. And what you multiply is the numerators and the denominators. So the numerators together, you multiply across to numerator to numerator, and then you multiply across from denominator to denominator. Okay? So that's what you're doing. And so let's look at some examples here. Okay. Let me put that factor, simplify, that's an M, and then you multiply. 1, 2, 3. Alright, so let's look at this example here. You got 2 a squared b over b squared c times b over a. Okay. First thing you want to look at is, can I factor this? Can I factor any of these things? Well, this cannot be factored, right? These two can't be factored. It's a b squared and a c. You can't factor anything out of this. There's only one term, so they're not factorable. However, you can, number 2, simplify if you look across from each other and find out what the factors are in these two. So between 2a squared b and a, you can pull an a out. So you would divide essentially an a from both of these. And when you divide an a from 2a squared over b, this is still just the numerator. The rule is, when you divide a variable raised to a power by another variable, by the same variable, you subtract the exponent. So whenever you have an a by itself, it's really just, when you have an a and no visible variable, it's understood that, visible exponent, it's understood that that's a to the first power. So what you're going to do is you're going to basically subtract 1 from 2 from 1, 1 from 2, right? And this is going to end up being 2ab now. Where it was 2a squared b, it's 2ab now. And this a divided by a is just 1. So now we can rewrite our problem. Oh, and we got the same situation with our b's, right? There's a b here, and there's a b squared there. So you divide a b from here, that's 2 minus 1, and you end up with b, c, and here is b divided by b, which is 1. So when you rewrite your problem, you'll have 2ab the top divided by BC times 1 over 1. Okay? And identity property is right here. So any number times 1 is that number. Any number times 1 is that number. So your solution then would be 2AB over BC. Okay? So what we did was we simplified the two fractions and then we multiplied. Okay? Let's look at another problem here. This next problem, you have to rewrite it or you have to distribute some things. So this is x squared to the third power all over 2 times 8 over x. Now, whenever you have a set of numbers in parentheses or you see a fraction in parentheses raised to a power, fraction raised to a power means that you have to raise both the numerator and the denominator to the third power. So you essentially have 2x squared to the third and 2 to the third. Now, the rule of exponents is whenever a power is raised to a power, you multiply. When a power is raised to a power, you multiply. So this is x to the 6th power over 2 to the third power is not 2 times 3. 2 to the third power is 2 times 2 times 2. So that's 2 times 2, which is 4 times 2 more, which is 8. So you got 8 here. Okay. Now we look at the other fraction where we had 8 over x, and we just bring it right back down. 8 over x. Okay. So now we haven't quite factored, but we simplified this. We rewrote the first fraction, and now we're going to see if we can simplify it. Looking to see if we have any like term, not like terms, but like factors that we can to take out a factor. So you have 8s here. That means you can divide both of these by 8. 8 divided by 8 is 1 here and 1 there, right? Now, here you have x to the 6th power, and you have just a regular x. And that means you can pull at least one x out of here. So you're going to divide x into both of these. So when you rewrite this problem, you'll now have x to the 5th, because remember, like I said in the last problem, if you have x to the 6th divided by x, it's understood that there's a 1 here because this x doesn't have a visible exponent. And when you divide variables raised to a power, like variables raised to a power, you're subtracting. So that's x to the 6th minus 1, which is x to the 5th power. Okay? So it's x to the 5th power over 1 times 1 over 1, because x divided by x is 1. Okay? So our solution then is x to the 5th. Multiply. X to the 5th times 1, 1 times 1. X to the 5th. Okay?